I come because I like to learn about what is going on in the industry. I like to hear from the contractors, especially because being an engineer, sometimes it's good to learn from the contractors what innovations they're coming up with, and obviously to meet with other folks and see what they're working on.
This conference is probably the most important event during the calendar year, so you cannot miss it. Because here you can meet a lot of people, contractor, supplier, competitors. So as I said, it's the most important event in the calendar for foundation business, and it's too important to don't be here, let's say.
We come because we get a lot of exposure to people who use our equipment. Camaraderie, a lot of camaraderie. Even with our competitors, we come out and we rub shoulders. Everybody knows everybody. It's just one big happy family.
Well, it depends on whether or not you want to continue learning. If you got a desire to continue to learn, then you need to be at DFI.
The good thing about this conference, you can meet a lot of people over and over, so you can make a very good connection with the industrial people.
Networking's huge. There's so many people here, just from different parts of the country and the state and the world even, and just seeing what processes they're using and their design methods and their equipment, and just really a lot of exposure, and also getting connected with those people for potentially future work, future jobs.
Come join us if you're interested in anything in this industry. This is the place to be. This is it.
Good evening, everyone. A warm welcome to all of you to DFI of India Groundwork Series 2024, Webinar 2. So before we start the program, here are a few instructions. So recording of this webinar is prohibited. However, the online recording of this webinar will be available on DFI of India YouTube channel in approximately 2 weeks. And also participation certificates for the student attendees will be emailed in approximately 2 weeks. So you can ask your questions for the presenter anytime during the presentation in the Q&A box as displayed on your screens. So coming to today's program, we have received more than 190 registrations from almost 12 countries. So once again, I welcome you all joining us today from different countries. So the sequence of today's program will be as follows. So first, the introduction of the speaker, Ms. Sayantani Ghosh, and her presentation on the topic, designing, building, and supporting structures in variable subsurface conditions in Manhattan, New York. Then we'll have a Q&A session. Then I'll give a brief update on the upcoming DFI of India events. So without any further delay, I would like to introduce today's speaker, Ms. Sayantani Ghosh, Principal Engineer from Langan International. Geotechnical Sayantani Ghosh is based at Langan's London office, where she works on stadia, developments, luxury resorts, mixed-use facilities, and super tall towers in the UK, KSA region, and the New York metropolitan area. Born and raised in India, Ghosh earned a bachelor's degree in civil engineering from the National Institute of Technology, Durgapur, in the year 2011, after which she began her career as structural engineer. In 2014, she earned a master's degree in geotechnical engineering from Virginia Polytechnic College, Institute and State University before moving to New York to work for Langan and then relocating to its London office in 2020. Ghosh has more than 10 years of experience in deep foundations, rock and applied soil mechanics, earthquake engineering, in situ testing, and field instrumentation. Major projects that she has worked on include the American Museum of Natural History Gilder Center, Brooklyn Methodist Hospital, Trojena, and Amala. We heartily welcome you, ma'am. So now I request you to kindly share your screen and you can start the presentation. Thank you.
Thank you so much, Sai, for such a kind introduction. Thank you, DFI India, for the invitation to talk about two of my favorite projects and especially to talk to students. I share my presentation. Yeah. So welcome everybody. We're going to talk today a bit about designing, sorry, uh, constructing and supporting structures in the variable subsurface conditions in Manhattan, New York. It's some of the things that we usually hear a lot as geotechnical engineers whenever we talk to clients or developers is that you are in one city for such a long time. So how come you don't know the subsurface conditions? So a bit of the background of today's discussion will be that how important it is to understand the subsurface conditions of a particular job site to appropriately design and also work with the contractors to have a successful project. So we're going to talk about two of the projects in New York City, which is one of the cities in New York State. So there's a lot of confusion a lot of times that New York is, it's a huge state. And what New York City is just one of the cities in the state. And the New York City is divided into 5 boroughs: Manhattan, Bronx, Queens, Brooklyn, and Staten Island. And moving on to Manhattan, if many of you would be aware that probably, and if you have heard about Central Park, so the site American Museum of Natural History, Gilder Center, is right next to the Central Park of New York, of Manhattan. And the other site that we worked on was Uptown Manhattan, which is 4650 Broadway. So what are we building? So taking a step back from any name of the project or anywhere it is. So for the site 1, it's a 4,500 square meter site, 4-story mixed-use building. It's surrounded by 40 to 130-year-old historic buildings. It was going to involve 6-meter excavation for the basement construction. Second site, it's a 5,000 square meter. Apologies, it's still feet, so apologies about it because it's a bit of, I know we're coming from US to presenting in India, so this is meant to be meter. It's a 20-story mixed-use building and a 2-meter excavation for basement. So how do we get there? How do we achieve the goals of the projects? So wherever the site is, irrespective of the location, we would usually take a step back and try to understand what are the available geology maps in the region. What are the historic maps saying about the historic history of a region? What was on site in the past? The local authorities, it's very critical. They play a very important part in the success of a project because they would be the one who are holding the information of these historic maps of what are the local compliance issues that we have to follow on, what are the code compliance that needs to be followed, what are the approvals needed. So the local authorities need to be on board to move ahead on the project. What are the existing geotechnical investigation reports available for the job site or in the vicinity of the job site? The adjacent structures, what if information is available for the adjacent structures, like how tall are the buildings? What is the depth of the foundation? How many levels of basements are there? How close are they to our job sites? Site visits, they are the most important according to me. It's very, very important to have site visits very early on a project to understand the locality, the region, the site grades. It's absolutely very critical for the project. Planning a very tailor-made subsurface investigation for the particular job site and what technologies are available at the moment and what technologies are coming up. Discussions along with discussions with the contractor very early on the project is very critical to not have abortive work and waste of time, resources, money on a project. So what we're trying to look here is it's different sites, but the basics are same. We follow the same basic, same uh, mantras for any job sites, irrespective of the location of the job site, not only in Manhattan, but anywhere in the world, I'd like to say. So these were the site 1 and site 2 of one of the geology maps, and we were looking at what are the bedrock conditions based on this geology map on both the sites. So now I'd like to go a bit project specific on Gilder Center, which I'm trying to refer as site 1 for simplicity right now. So the Gilder Center, the most critical part of this job was it's a landmark site in a historic district. It was surrounded by buildings which were built ranging from 1877 to coming to 1929. So these were really, really old buildings with very old foundations, and there was no way we could touch them. It was very stringent restrictions uh, on any sort of damage that can occur to these buildings. And I'd like to flag it's an operational museum. So it was the entire time of construction, the museum was operational. There were visitors, there was guests, there was ongoing shows. So it was a full-on operational museum along with an active construction site going on adjacent to it. So how did we start the project? We started the project with planning a field investigation, which comprised of geotechnical borings, trial pits, and laboratory testing. As you can see, based on this project where we had all these adjacent structures, but unfortunately there was no information available in the local agencies or in any kind of websites with the building information where we could have found that what is the existing foundation of any of these buildings. So we prioritized trial pits on the job rather than doing tons of boreholes, because it was very important from early on to understand that what are the subsurface conditions where the existing footings are bearing on. So a high level overview of the subsurface conditions of which is the east-west subsurface profile. We found out that the site is underlain by fill, which was underlain by a clay zone, and underlain by a combination of competent bedrock, sand, and decomposed rock. So you can see it was highly variable. We could not state that, okay, the site is going to bear. The red line here is showing the level of the proposed, the new cellar level. And that level was going to range, the bearing level was going to range from competent bedrock to sand to decomposed rock. Now moving on to the north-south subsurface profile, and it was very similar. We understood that the existing foundations were going to bear on either decomposed rock or right now bearing on decomposed rock or bedrock. So these are a few of the pictures from our test pits and while we were exposing the existing foundations. So the adjacent footing material was either concrete or stone, and the existing footing, as I mentioned earlier, that was bearing either on decomposed rock or on bedrock. So the support of excavation was very, very critical on this job. So moving on from the east side of the north of the site and north and the east. So the buildings were on the north and the east side of the site were bearing on competent bedrock to borderline decomposed rock. And we had to do concrete piers to lower 6 meters and bear the new foundations, which was done with the concrete piers onto competent bedrock. And as you can see, the blue zones are showing active utilities. So the active utilities had to be underpinned and supported, and these were really very high intensity boilers. And so it had to be, a lot of safety procedures had to be put into place on site for the safety of the workers and the engineers who were working alongside active utilities. If we move to the west side, we had a soldier pile and lagging system, which was on varying subsurface conditions, because when the southern part of the site had the rock level way higher than the northern part of the site. So the level of tier of bracing were determined as we were going and excavating on site, moving from south to north, depending on where we were encountering bedrock. The proposed new foundations was a combination of shallow and deep foundation. So it had shallow footings, which had a range of, which was bearing on 4 TSF sand or which was bearing on 20 TSF bedrock, depending on the column loads received from the structural engineer. And then the deep foundations were caissons with sockets into bedrock. The key considerations for the job while designing and while also construction phase was we had to limit the differential settlement to the limit of 1/2 inch, and the total settlement and deflection was not allowed to be going higher than 1 inch. These were some of the pictures. As you can see that the bedrock is dropping. So there's a valley condition which was ongoing on site. So this was a bedrock which was going which was sliding down, and we were preparing this. This is a picture of a preparation of a subgrade for a shallow foundation. And then on the other side of the site, parallelly, there was caissons which were getting constructed. As you can see a picture that it was an extremely active site with almost 5 or 6 types of different construction activities or drilling machines ongoing, with active utilities running as well. Moving on to the second site, which is 4650 Broadway, the same principles of planning and very appropriate and tailor-made field investigation for the site, which comprised of geotechnical boreholes, seismic cone penetration tests, a geophysical survey, and laboratory testing. So what we saw in the subsurface conditions here is we encountered a 15-meter thick overburdened soil underlain by decomposed rock and which was underlain by competent bedrock. Moving on to looking at another section of the site, similarly, we saw a 20-meter thick overburdened soil underlain by decomposed bedrock. Some of the pictures of the different kind of rock. So you can see one of the boreholes we saw decomposed schist. However, on the other side, we saw white marble on site. So now when we looked at, based on the loads that we had received, this was supposed to be, getting inclined more towards a deep foundation design. So what are the options of the deep foundations? Drilled piles, driven piles, CFAs, continuous flight auger piles, mini caissons. So when we were looking at what are the key considerations on the side, we had variable bedrock conditions, we had a very thick overburdened soil, and we had sensitive adjacent buildings next to the site. However, this was a very sensitive locality with extremely sensitive neighbors who were not willing to accommodate with any kind of disturbance due to sound at all in the area. So when we looked at the initial design by Langan, we were looking into 2 different kind of CFA piles with a combination of mini caissons. However, the contractor was involved very early on the project, and they put a proposal in the front that the contractor sees a potential cost saving and expediting the program of the site, with validating that how much depth of the piles are determined based on load tests which will be conducted early on the project. So we were willing to work with the contractor on the project to develop the criteria. Instead of putting the criteria that we had thought, we were willing to work with the contractor to develop the criteria based on the load tests, based on the QA/QC process, which our engineers would be following on site. So moving on to so we performed compression load tests, tension load tests, lateral load tests on the job. And what were the QA/QC process which were implemented on site was the CFA machines had automated monitoring equipment, which was documenting real-time grout volume, theoretical pile profile, drilling rate, grout pressure. Our engineers were on site constantly documenting all this information on site, while parallelly, the office design team was running our numbers to come up with a parallel QA/QC process of putting a place of a smell test of if the grout volumes are matching, if the pressures are appropriate for the kind of material we'd like to have the sockets going to. And then we were going to validate these results with instrumented load tests to be able to come up with a very efficient QA/QC process on job. We additionally performed some thermal integrity profiling tests, which documented the pile integrity, concrete quality, and the pile shape. So the conclusions for both the sites were very planned subsurface investigation in the initial phase of the project helps on keeping the project on the right track and avoiding any significant surprises during construction. Any significant surprises during construction can be has a very big impact on the cost and the timeline of the project. The key considerations and having the key considerations fixed during the start of the project to develop it as we go ahead are important to come up with the appropriate design. Team coordination of all the relevant parties, the client, developer, structural engineers, geotech engineers, the local authorities, the contractors, and anybody who is important in the project needs to be constantly in touch and constantly coordinated to avoid, again, any surprises between parties or which leads to significant delays on the project. Having an appropriate applicable support of excavation design early on in the project and having a QA/QC implemented while construction of the support of excavation is very important for safety in the region. Extensive quality assurance and quality control on site is beneficial for all parties relevant to the site. And bringing in the contractor experience from the very early on of the project helps in any miscoordination between the design team and the construction team, because it's a very love-hate relationship between the designers and the contractors. We need each other and we need to work with each other to make a project successful. So thank you. This is my presentation for now. I'm happy to answer any questions.
Thank you. Thank you so much, ma'am, for such a wonderful presentation. So now we are open to question and answer session now. So I request all the audience to put their questions in the Q&A box as displayed on your screens. We got a comment from Mr. Sanjay Gupta. Very nicely explained. Thanks.
Thank you.
And a question from Dr. Sunil Basarkar. Any confliction with the designers during executions?
Sorry, can you repeat your questions? I couldn't, you were breaking.
So the question is from Dr. Sunil Basarkar.
Hi,
Any
Dr.
confliction with the designers during executions?
No, we did not. So fortunately, we were able to work with the design team, and the contracted teams were involved very early on from the very beginning of the project. So there were no surprises for any parties. Of course, there was some disagreement, especially on Natural History Museum on the bearing layer during the QA/QC process, which we think competent. Like I was personally on site during the entire construction of the American Natural History Museum site, and I was very heavily involved during the construction of the 4650 Broadway as well. So there's every day to day sometimes we don't some the designers don't think something is competent, but the contractors do. But high level conflicts, no, there was not, because we did work with them very early on the project, and we resolved any kind of conflicts before the jobs went into construction, which really helped in expediting the timeline of the projects.
Sure. So there is another question from Mr. Arnab Chaudhary, ma'am. How to balance the earth pressure in time of trial pit construction nearer to old existing foundation?
That's a very good question. So we performed local sheeted pits, and it was we had, and honestly during the underpinning well, some of the trial pit construction we were going through some really soft clay zones as well. So there was a very stringent dewatering system installed on site, and the sheeted pits were, it was a braced sheeted pit that had to be installed on site. And we tried to not keep the pit open for a long time, and we were able to, it was going on really long shifts, but we were able to put concrete back into the pit within 24 hours of starting to excavate it. So yes, there was a very stringent QA/QC process put on site whenever there was a deep trial pit constructed on site.
Sure, ma'am. So the next question is from Mr. Alok Bhaumik. Can you give some detail about caisson foundation that you referred in your presentation? How are these caissons constructed?
Sure, Alok. So the caisson is really, it's a term used when you have a drill shaft which is extending to bedrock. So there is a steel casing which is installed with maybe a half a meter embedment into rock, and then there is an auger which extends below the top of rock to the socket. We call it rock socket, which is constructed, which is drilled. There's different kind of machines, some, and based on the locality, like it depends if you can use, what kind of hammer can you use, or what kind of drill bit can you use, based on the local agency compliance regulations. And that is how the socket is constructed. That rock socket takes on the load which is transferred from the columns to the rock layer. I am happy to have a, if you want to reach out to me, and I'm happy to have like a discussion specific on caissons, if that's something that you'd like to talk.
Sure. So the next question is from Mr. Mohan Ramanathan. In one of your pictures, you showed a drum cutter being used to shape the neighboring structure. Why was this attachment chosen for demolition?
Yeah, that's a very good question, Mohan. So we had to so there was rock faces which were coming onto our site, and we had to trim it to have very a flush face for our site, our wall, our foundation wall to go flushed with it, and it had to be trimmed. And I just want to flag it, there was a very stringent monitoring site monitoring system that was also installed. So there was a 24-hour monitoring that was ongoing on site, and it was constantly, whenever we were getting any vibration alert, then the construction activity would be stopped. So which wasn't the case, we hadn't exceeded that. So there was a parallel monitoring system that was installed, especially when as you saw when the drum cutter was used to shave the neighboring structure. The only purpose was we had no space. We had space issues on our side, so we had to have our foundation wall flushed with the neighboring structure.
So the next question is from Mr. Hemant Vadalkar. There seems to be variable depths for pile socketing. Does that pose any problem in a pile group with variable depth piles?
So that's a very good comment. So and question. So we have not had different. So the pile groups were, again, this whole exercise was in a very close coordination with structural engineers as well, and we did not have much variation in the pile depths within a pile group. So that wasn't the case. There was a bit of variation based on the material, but we hadn't seen that in the same pile cap. We were now talking about a 5-meter variation or so. So the variations was more going from zone to zone, but it wasn't a significant variation within the same pile group. And we were constantly reporting things to the structural engineers as well. And there was a parallel redesign process. It was ongoing on their end as well. So that coordination was also going on parallelly.
So the next question is from Mr. Jitin, ma'am. Thank you, ma'am. Just a query. At what point of the stage during the execution of the project we involve the numerical analysis of these designs? Does this project involve any? If yes, can you please give a brief?
So yeah, we did perform, like, yes, both the projects had design analysis going on. However, we did not have required to do any numerical analysis on any of the two projects. So numerical analysis is usually done when we have a raft going on in the entire site, or it's a pile supported raft. So it's also job specific. So I think it goes on from job to job that which job is required to do what kind of design. These two jobs we did design analysis, very extensive design analysis. But if you are referring to 3D numerical analysis, then that is not something that we needed to do in any of these two jobs.
So another question from Mr. Arnab Chaudhary. Ma'am, will deep mixing column not be a good alternative in the place of trial pit for site 1?
So, sorry, when you say trial pit, are you, I think, are you referring to the concrete piers? Because we did trial pits to understand the subsurface, like what is the foundation of the existing building. That is what we were excavating for the trial pits. So so apologies, I'm not sure about if I'm missing out something, but the trial pits was a part of the subsurface investigation. And if you're talking about underpinning, then the underpinning of the active utilities that we could not have brought a drill mix machine next to that active utilities because of the sensitivity of these utility structures. We could not, even the caisson rigs that was coming to the nearby pile caps had to maintain a certain distance to not cause any vibration at all to these utilities. And that is the reason why we had to do very localized underpinning pits with active monitoring. I think, if I'm not wrong, I think you were referring to the underpinning pits.
So hope Mr. Arnab, your question is answered. Otherwise, you can write to us or even to ma'am. So another question from Mr. Mohan Ramanathan. What was the limits of noise and vibration? Did you follow NYC specs?
Yeah, we did follow NYC specs. I I don't recollect the noise limits at the moment, but yes, we did follow New York City specifications. And as I said, for the vibrations and for the noise, like there was a very stringent monitoring which was installed throughout the site, which had to be approved by New York Building Authority. The New York City Building Department has to approve. It's a requirement to get every drawing approved by them. And there's constant visits on site regularly, surprise visits, I have to say, when they come to site and they ask you for it. Honestly, for especially the Natural History Museum side, there was weekly visits and without any prior notice. And whenever they would be on site, they wanted the entire detailed monitoring reports to be shown to them right at the moment without any heads up. So we had to be always ready on site. And if they noticed any variation from the compliance limits, then that would be a stop work order right away at that moment with a very heavy fine. So we had to really be on top of our like on the job about following the rules and regulations on the job.
One more comment from Dr. Sunil Pasarkar, ma'am. Thanks for your reply. Variations are norm in many of the projects. Thanks for bringing this as a record.
Thank you so much. Thank you for saying that.
And from Arnab, ma'am, thank you. I got the answer. I was referring the underpinning part only.
Yeah, deep soil mixing is I have a different job on that. So feel free to reach out to me and we can have a chat on deep soil mixing for sure on that. So that's another job which is entirely on deep soil mixing. And I see Alok has about Caisson Foundation. So yes, surely please reach out to me. I did show my last slide. So my email is sghosh@langan.com. You can reach out to me on LinkedIn. I'll be happy to talk about Caissons whenever you want to. Thank you.
Thank you. Thank you so much, ma'am. So this marks the end of Q&A session. So once again, we thank you a lot for accepting our invitation to present in the Groundwork Series 2024.
Thank you so much for the opportunity. Thank you for all the questions. And it is my honor to be able to present today on two of my very favorite projects. And anybody who attended and would like to have any chat on anything related to geotech, feel free to talk to me. I would love to do that. So thank you so much again to everybody.
Thank you. Thank you, ma'am. So this marks the end of the webinar. So now I would like to give a brief about the upcoming DFI of India programs. So we have the webinar 3 planned on 12th April 2024 at the same time, that is 5 to 6 p.m. IST, on the topic MTHL Foundation or piling aspects, challenges, innovations and developments. The presentation will be delivered by Mr. Kiran Kulkarni, and he is the General Manager at Tata Projects. So, and also another online webinar is happening tomorrow, that is at 9:30 to 1:30 p.m. It's a workshop, kind of mostly presented. Several national and international experts in the CFA piling industry are going to be presenting in this program. So I encourage all of you to register for this program and get a chance to interact with these experts. And also, so most of you are already aware, DFI of India is having its annual conference in September this year, that is in Goa, during 19 to 21 September 2024. So we are overwhelmed with the response, and we have got almost 160 plus abstracts for this conference. And I encourage you all to register for this conference as well. So the registration will be open soon. That is mostly in the second week of the April. So I encourage you all to register for this conference. And With a heavy heart, we inform you about the sad demise of the two stalwarts in the Indian geotechnical fraternity, that is Dr. N.V. Nayak and Shri Anil Lonthe. So we hope the family finds strength to cope up with the irreplaceable loss. So this marks the end of Groundwork session 2. So once again, I thank all for joining us today. And you join us back during Groundwork session 3, which is scheduled on 12th April 2024. Thank you.